Mass spectrometry. This video is an introduction to mass spectrometry. Mass spectrometry is used in conjunction with other spectroscopic techniques to determine the structure of the organic compounds. It allows us to determine the molecular mass and molecular formula of a compound, as well as some of its structural features. In earlier days, the molecular weight of the compound was determined by its vapor density and freezing point depression, and the molecular formulas were calculated using elemental analysis. These procedures are long and tedious and also require a large amount of sample. But now we do have mass spectrometry, and the technique is very simple, and the most important thing is it only requires a very, very tiny amount of the compound. In mass spectrometry, a small amount of the compound is introduced into mass spectrometer, which is first vaporized and then ionized. When you say ionize, you're going to remove an electron from each molecule. Ionization can be done in several ways. The most common method for the ionization of the molecule is through electron ionization, also called as the EIMS. In EIMS, the vaporized molecules are hit with a high energy beam of electrons. The energy of the beam can be varied, but typically it falls in the range of 70 electron volts. Now, when an electron beam hits the molecule, it's going to get an electron ejected from the molecule, and it produces what is called as the molecular ion. The molecular ion is basically a radical cation because it's going to have an unpaired electron and also a positive charge on it. We can also do the chemical ionization where the sample is sprayed with a pre-ionized gas such as methane or ammonia, which causes the sample to ionize by electron transfer or proton transfer mechanism. But both of these methods are only applicable for relatively low molecular weight compounds because both of these methods require the sample to be vaporized before it is ionized. For larger molecules, for even larger biomolecules such as enzymes and oligonucleotides, what we can use is desorption ionization. In this technique, the sample is first dissolved on a matrix compound, and then it is ionized by one of the several ionization methods that we have. The matrix compound is going to transfer energy to the sample, causing some of the sample molecules to ionize and then finally eject from the matrix. And the ejected ions are analyzed finally. So the ionization that is used for bombarding the matrix compound can be one of these different ways. The first one is SIMS. SIMS is basically using high energy beam of ions, also called as the secondary ion MS. Or through photons, which we generally call as MALDI. MALDI means matrix assisted laser desorption ionization, or by neutral atoms, which we generally call as FAB, which represents fast atom bombardment. Here's the working of mass spectrometer. Let's say you're going to inject a sample into the mass spectrometer. Now the first thing that's going to happen here is the sample is going to get vaporized, right? And then it will be ionized using a high energy electron beam. As I've said before, the energy of this electron beam is going to be 70 electron volts. So when the high energy electron beam is going to hit the molecule, hit the neutral molecule, it is going to produce what is called as the molecular ion. Remember, the molecular ion is a radical cation, and it's going to have an unpaired electron and a positive charge. And also remember that this electron bombardment is going to inject so much of kinetic energy into this molecular ion, and it is going to break into different fragments such as cation, radicals, neutral molecules, and other smaller radical cations. Obviously, the bonds that are going to break are the weakest bonds, and those that results in the formation of the most stable fragments. Now, after this, all the positively charged fragments are going to get attracted towards these negatively charged plates and are accelerated to the analyzer tube. And the neutral and negatively charged species are going to get sucked out of the system using a vacuum pump. So remember, the mass spectrometer is only going to identify the positively charged species. It could be the molecular ion, or it could be cation, or it could be other radical cations. It is not going to identify the negatively charged species or neutrally charged species. The analyzer tube is surrounded by a magnet, which is going to deflect the positively charged fragments in a curved path. At a particular magnetic field strength, the angle to which the path is curved is going to depend on the m by z value, mass by charge ratio of the fragment. In general, particles with a smaller m by z value is going to bend more than the ones with larger m by z value, and they are expected to come out first to the ion exit slit. And all fragments are collected separately at the ion exit slit, and the collector is going to record the relative number of fragments with a particular m by z value passing through the slit. Remember, the more stable fragments are not broken down further when they are collected at the collector. And also, we can increase the strength of the magnetic field so as to let all the fragments with even larger m by z value, to come out of the ion slit so they can also be analyzed. The mass spectrometer then finally graphs a plot between relative abundance of each fragment against its m by z value. Now, since the z for each of these fragments is going to be +1, which basically the charge of each fragment is going to be +1, the m by z value is nothing but the mass of the fragment. And since the molecular ion, the fragment ions that are produced in a mass spectrometer are unique for each compound, the mass spectrum can be used like a fingerprint to compare the compound's identity.